Good evening to all of you.
So now we'll have our esteemed guest to have his lecture today. Over to you, sir.
Just can you hear me though?
Yes, sir. You're
Okay,
not too
cool.
audible.
Yeah, hi. Also, I mean, before I even start, so what is the timeline that you're looking for? Maybe about 30 minutes to 45 minutes?
We'll have 1 hour, means like 30 to 45 minutes of your guest lecture, and we'll have a Q&A at the end.
Okay, fine. Yeah, let's see. Let's see how long it goes. I've made a few
Yeah,
slides, but
sure, sir. Yeah.
I think it went to the wrong screen. Give me a minute. Yeah, can you see my screen?
Yes, sir.
Wait, I think now this should be the proper screen, correct?
Yes, sir. Yes, sir.
Okay, good. So I think good evening to everyone. I cannot see your faces, but yeah, I hope you had a good weekend right now. I think it's Sunday evening at your end. So I really hope that you do a relaxing weekend and you're ready to start your week from tomorrow. So you must be thinking, who is this guy? Why are we sitting here on a Sunday evening? We're probably wasting half an hour, 45 minutes of my time. What can he tell us that we probably don't know, right? Pretty much, I was the same way when I started, when I was in my first and second year. But then over time, as you grow older with age, with experience, you realize your own shortcomings in a way of what things you could have done better that you missed. You realize that the world is much bigger than what you think it is, and this is my way of essentially giving back to my college, and let's say people who are at the same stage of life where I was a couple of years ago, so that they can develop, not make the same mistakes that I have made. And also, I mean, for me to help you guys probably find a career path, right? So uh, the agenda is, it's just three short points. One is questions about me. So essentially, who am I? What did I do? Where am I from? How have I done things in my particular life? Essentially, then talking about robotics specifically. So, what is robotics in general? What are the different aspects of robotics? Uh, Different resources from where you can start learning about robotics, and then again, in that journey, what are the mistakes that I have made, specifically coming from a mechanical background, and then how you approach robotics in that sense. And then finally, if we have enough time, we can talk about my, like, grad school application journey, which is what a lot of you will be doing in a couple of years. Just to confirm, you can hear me, right?
Yes, sir. We can hear you, sir.
Okay, fine. Yeah. Also, again, as I said, right, specifically I've put in a section on regrets, so we can go over that as well. And finally, we'll have the Q&A, right? And also, thank you so much for giving me this opportunity to talk and present. So really thankful for all of you.
Sure, sir. It's a pleasure hosting.
Yeah. So I joined NIT Trichy in 2016. So I am actually from a small tier 2 city called Aurangabad in Maharashtra. So from there, in my first year, I was able to get inducted into Designers Consortium, which is like the product designing club of NITG. Uh, I have done 2 implant trainings, one at Garware Polyester and one at Anderson Hauser. I'll get to it why these were quite critical for me. I have 3 internships that I have done during my degree. One at IIT Bombay, one at ISC Bangalore, and one at ExxonMobil. I'll also in subsequent slides I'll go over what were my specific projects, and I have 1 year of work experience in India, where I actually got my PPO converted in ExxonMobil where I work. So I'll talk about this as well in the later slides. Uh, so after my experience at Exxon, then I moved to the US to pursue my master's in mechanical engineering. Here is where I had a specialization in robotics and design. Essentially, a lot of the robotics knowledge that I have, I've learned it from this, and I have worked in a research lab. It's called the LC2 lab, where they do cement 3D printing essentially. So I'll talk about this project as well later. I interned at a company called Intuitive Surgicals. So if you have ever seen the surgical robot, and if you have seen the grape surgery video on YouTube, where there's a surgeon who puts on a VR headset essentially and then does surgery on a grape and remove the skin. It is the same company, and right now I work at Applied Materials. So yeah, I mean we'll talk about that as well. So it's applied Materials makes the equipment that makes a semiconductor chip or a wafer as we call it. So starting with my projects, right? So I think the projects are something that I hold really close to my heart, because the one thing that I've tried to do a lot over my entire degree is to have as many projects as possible. The projects were always motivated by my own interest in a way, and so this is the on the left, the UC VRX80, which is one of the first projects that I've done. This is part of the Designers DC Club project. Essentially, we had a general problem statement that we had to lift some loads, and for that we came up with a particular mechanized solution. It was pretty cheap, like $30,000, 30,000 rupees actually. So that was pretty cheap as well. This is like one of my first projects, right? Then my next project specifically was this project, the series elastic actuator, which was uh, when a robot jumps in the air, the legs have a lot of jerk, right? And that jerk, to counteract that jerk, I came up with this particular mechanism, which could reduce the jerk on the motors. Now, why am I talking about my projects, right? That is the bigger question. I wanted to highlight the particular fact that when I started with the project on the left side, that is the VRX project, right? I could barely do designing, right? But because I did the project and I learned designing while I was doing this project, that is why I got my actual internship at ISC Bangalore. So this is one of the ideas that you will consistently see through this lecture that I'm trying to give, is that you have to start somewhere. I mean, no one will offer you an internship because you want to do it. You have to provide value in some way to the professor, to the company, and that is when you will get an internship. So the message here is start doing something, right? Uh, these are my UCLA projects, where it's a pretty massive project. So how you can make a difference between those two is that this is a pretty small project. It's very simple. Uh, as you develop more and grow more, essentially your projects will become more complex. So the one on the left side essentially is a big, massive 3D printer. The plan is to print cement, carbon neutral cement, essentially with uh, an open source software, essentially, so that the plan is to be able to print houses in the future with this kind of setup, right? And then on the right side, you see like a simple robotics project where you are trying to play tic-tac-toe with a 4 degree of freedom robot arm. This is one of the group projects that we had. I'll come to these two projects later because these are related to robotics specifically, but I'll talk about them later. Right. So the key learnings that I have are threefold, right? Most of the people, they think that, oh, when the companies come during the third year, that is the time that we'll start preparing for internship, and that never works, right? Because at that point of time, if there are your teammates or your classmates essentially who have done multiple internships before that, they will get preference during the CPCs and the this thing. So that is the first thing, right? That you have to start somewhere. So that's why if you see this, look at the second point I've put in there, right? You can start with anything. You can start with just doing simple workshops, RMI, DC workshops. You can work with your professor. You can go to competitions. It does not matter if you fail, right? It's about finding what you really like. It's about finding that one thing that you have some joy in, and then when you learn that thing, as I said, right, you just get inspired, get one thing that you really like, you fail, you will rise over and over again, and you will eventually get that thing. My interest in robotics, I mean, it came pretty late, right? The first thing that I learned was designing, right? Like modeling, making mechanisms and linkages, right? And then at some point of time, it was, oh, I can make a design, I can make a mechanism, but I cannot actuate it, I cannot move it the way I want. Then I was like, oh, then let's learn about servo motors. Okay, now I learned that. Now let's learn about DC motors. Then, okay, fine, I learned that. Then how do I have a better control of it? Then I learned about Arduinos and Raspberry Pis, and then I learned about Python. So essentially, again, this is what I'm trying to say, right? It's a butterfly effect. Like you start with something very small, right? An idea. And then eventually, as you keep building on it, and chaos theory says that you will get better at it and it will become something big. And I think I really live by this funda because I'm here. I mean, I could never, if you ask me when I was in my third year, hey, will you ever be at UCLA studying robotics and being in a fancy robotics company? I could have never believed that. But here I am, right? And which it's just this exact same reason I want this to be an inspiration for you guys, and as well as an inspiration that you should find your own inspiration. Whatever you like, you may or may not like robotics, right? But whatever you should find something that you really like. That is the key takeaway that I have. Second, no knowledge ever goes waste, right? I have lived this because even the most random, stupid things that I have learned at NIT Trichy, you may say that, hey, this no one will ever ask me these questions, and I've been asked those questions in interviews, and I've been able to answer those questions. One of the specific incidents I want to highlight is basically during my one of my interviews. They asked me how to find the breaking force of two plates rubbing against each other, right? And it might seem, I mean, people generally tend to forget this, but the fact that you're able to use your brains and remember what has been taught in class and give that interview, it's a surreal feeling essentially, right? That when whatever is being taught in class is actually being applied to whatever you do every single day. I still use whatever has been taught during my JE prep and gate books every day during my job here, right? Third, skills, right? As I said, they do not develop in one day. You can write whatever you want in your resume, but they take time to develop. So you should give yourself the time to develop those skills, right? You should not be hard on yourself. Hey, why do I not know this? Why is it taking so much time, right? Start slow, start small. As you give it enough time, you will get better and better and better at it, right? The third thing. The fourth thing, again, it's something like a butterfly effect. It's essentially that networking with seniors will give you multifold returns, right? One of the internships which I got was through talking to a senior, right? So I had applied to like hundreds of professors, but no one was responding, which I think is the case with you guys as well at this point. But it turned out that one of the seniors, he had interned in the same lab the last year. He helped put in a good word for me, and I got that internship. So networking with seniors, so this is for for essentially like advice forever, right? Networking with whoever, networking with your mentors or your seniors or your professors always helps, because they will know people who are in a better position than you are at this point. So always network with seniors, always keep in touch, even during job search, right? So in India specifically, you have placements and companies come in, but if you go for masters and all these other places, you will have to develop your own network, right? And that's why if you develop this, or if you inculcate this habit of networking early on, it'll really help you in your career later, right? The last point which I wanted to say was, uh, it's relates to the same point where no knowledge ever goes waste, right? I remember during one of the summers, I was bored in the first year. After my first year, we had two months of summer vacation. I was bored. I had nothing to do, right? I could have just watched Netflix and done, do nothing basically. But I decided that my uncle works in a small company called Garwari Polyester. So I was like, okay, fine, I'll go and check it out. It turns out that it was a chemical manufacturing company. They made polyester and polyethylene, which are like two chemicals that we use to make bags and whatnot. Now, I went to that, I did my implant training, and I forgot about it. 2 years later, when ExxonMobil came to for campus interviews, I had put it in my resume that I have worked at Garwari Polyester, and the interviewer knew about the company because ExxonMobil makes plastics, right? So he talked about that, and he was really happy that I had worked there because I knew a lot of things about plastic at that point of time. So again, unless you build experience, unless you do things, you will have nothing to talk about. A lot of people during my batch as well, they face the same issue. When they reach the third year, they was like, oh, we have nothing to write in our resume. How do we fill 2 pages? Then some people either just do a few random projects and put it, I don't know, copy paste from the internet. But unless you can talk about the things that you have done, what difficulties you faced in your project, unless you can talk and you can explain it to the other person what in detail what you have done in your project, it's going to be a very difficult even to get interviews, right? I think yeah. And then I have two graphs at the bottom. uh, they talk about specifically GPAs, right? So a lot of people put too much emphasis on GPA, and then eventually lose out on their social life. And essentially, they put too much what do you say, emphasis on their GPAs, and then because they lose out on their social life, they lose out on the extracurricular activities that they could have done. I don't know, clubs, competitions, things like that. GPAs are important. You should definitely maintain a good GPA. I'm not an advocate of letting it, slide basically at the cost of other things. But if you know that you have a good enough GPA, then you should absolutely focus on your extracurriculars, right? And then you can see that maybe till your fourth year of college, everyone will ask you what your GPA is. Once you get out of there, no one will care what your GPA is, right? And that is true across. I mean, even if you go for masters or anywhere, that's true, right? GPA, people only care until you are in college. After that, it's all about skills, right? And so eventually, skills matter, and the value that you can provide to an employer, to a professor, is all that matters. uh, the last thing is electives, right? So I think my batch was, I think, the second batch where we had the option of choosing electives. So again, same, what people do is, oh, I want a light schedule for this semester, so I will take a easy course, like to the left of this line. I have somewhat interest in that, and it's an easy course, so I'm going to take that, right? And that is how, unfortunately, how most of the people choose electives. That is not how it should be done. Electives should be see, program electives are different, but the open electives, right? They are a way for you to expand and broaden your horizons, right? To understand things that are nowhere related to what you do. A personal anecdote specifically here is that I did a course from ECE on digital image processing, right? And when I went there, it was crazy difficult for me because that was not my domain at all. It was not my domain. It was like really difficult for me, right? And I actually got a kind of like a bad grade in that course. But that same course helped me, like multifold during my master's program, where I had to know. So because that course built a foundation for me, I could do my master's degree really well. Similarly, I took a control systems course from I think electrical engineering, which again helped me during my master's. So yes, I know that my GPA slightly suffered because of that, but I was able to broaden my horizons and I was able to learn things which I would have never learned if I just did purely mechanical courses. And that helped me, especially because I was trying to do robotics, where it's very multidisciplinary. Anyone has any questions for now, or do you want to take them later?
So we'll ask the audience. Audience, if you have any questions, please post in the chat box. We'll consider those questions at the end.
Okay, sure, yeah. So that was about essentially what I have done. Now, this section is to talk about robotics in general, right? So these two definitions I have just picked up from Wikipedia, right? So I will just do the task of explaining the definition right here. So everyone knows what a robot looks like. But we have to think of it from an engineering perspective, right? What goes into making a robot, right? So the first point, which is the most important one according to me, is that it is extremely interdisciplinary. You cannot say that this is the boundary of robotics, that this is the mechanical part, this is the electrical part, this is the software part. It is a very blurry boundary, because whatever changes you make in the mechanical system or design affects your electrical things, affects your software things. So it's extremely interdisciplinary. That is one. But so the definition essentially is that it's an interdisciplinary study of the design, construction, operation, and use of robots, right? So we as mechanical engineers mainly focus on the design aspect of it, design and construction, which is basically the manufacturing of it. We'll actually go into detail on what the other domains of robotics are, but right now our focus will be mainly on the mechanical aspect. You see the 4 images here are all each different types of robots, right? This is a legged robot. It's completely different control architecture. This is an underwater robot, so where you need to ensure like there are no leaks, there's high pressure, so it has a different types of motors and everything. This is extremely low pressure, as you know, like this Mars almost has no atmosphere, right? And then there is background radiation and whatnot, different challenges. And this is a simple robot arm, so it's a different challenges where you need to have it faster, you need to have it reliable, no downtime. So even in robotics, what I'm trying to say is that there are multiple applications. Each one of them has its own set of challenges, right? One additional robot which I wanted to showcase in particular is the robot that you see behind me, right? This is the robot that I worked on. Still like, oh, this doesn't look like a robot. This robot actually goes inside the human body to do the surgeries that you know. So it's called robotic surgery. This arm here actually goes into the human body, and then with a single point, like there's only one single point. It's called remote center motion. It is able to access your entire abdomen cavity. So this is like a 5th type of robot, which I did not include a photo for. It's called a surgical robot. So here I'll talk about basically the different domains of robotics. So as mechanical engineers, we tend to stick to this particular aspect, but there is no reason why you should just stick here, right? So a lot of people, like friends that I have from NIT Trichy, they did mechanical engineering and then they moved to control systems engineering, and some of them moved to essentially doing ML AI as well. So I mean, as you guys know, that is like really a trending and hot topic these days. So I'll actually go in detail over each particular domain, right? And how it relates to a robot. So the first is mechanical engineering, right? Where you essentially design the links, right? What should be the structure, right? If you apply a set amount of force, will a link break? How much force you should apply to move it at a particular speed? All of that dynamics, right? So you do all of these simulations in SolidWorks, in ANSYS, like structural simulations, everything. The second one is computer science, obviously, right? So anytime you want to have high level instructions to the robot, high level as in you want to tell a robot, hey robot, move forward, right? So when you tell a robot to move forward, that high level command is basically through computer science domain in that sense, right? Where essentially you ask a robot to move forward, and then that high level instruction is converted into low level code, that is actual motor motion that happens through embedded system. So that we'll come to that later, but all the high level commands are executed through frameworks such as ROS. uh, you develop those same modules for perception, planning, and control. Perception means how a robot is able to view and understand the environment around it. Planning is if a robot has to move from this point to this point, it's not as simple as moving in a straight line, right? There are so many things in it. It has to sometimes avoid obstacles. Control is if you ask it to go a particular trajectory, like maybe to paint a stroke, to paint a line. If you command a trajectory, it should follow that exact trajectory. That is what is called as robotics control, right? There's a separate domain for it. It's called control systems engineering, where you have stability, state space control. So stability, essentially a system is like, let's you take simple system such as an inverted pendulum, right? And if you do not apply any force to that pendulum, the pendulum will fall down, right? But what you try to do is apply some set force, that which is not fixed obviously, but a varying force, such that a pendulum is always suspended inverted. That is basically called as stability of a system. You're trying to set a set point and achieve that set point. That is stability. There are multiple ways to achieve stability. For example, I can give a simple example, right? If I take this phone, and if I just leave this, it's going to fall, but I'm applying a set force with my other finger to keep it in this position. That is called control. That I am commanding it to be in this position, it is actually being in this position. There are multiple types of controllers. I will not go into the details, but a few types are PID, LQR, and MPC controllers. What you need to do to implement these controllers is to be proficient in either Python or C++. You simulate a robotic system, right? You say that, hey, if I apply this particular force, how will the system react to it? So you should be really good at solving differential equations to be good at control systems engineering, because it is all about dynamics, right? You know how a system is going to react. You apply a type of force and it reacts in a different way, and that is what you simulate and you try to control, and that is control systems engineering. The next one is computer vision, machine learning, deep learning. All the cars that you see on the road, the autonomous driving cars, right? What they're doing is they are looking everywhere around with cameras, with LiDAR systems. They're making a map of the environment based using essentially deep learning techniques. And once you know the map, then they are able to find a way through that particular map. They are capable to avoid humans, capable to avoid future scenarios which may happen. Like let's say a car is coming from this side. They're able to do all of that with computer vision, machine learning, deep learning. Embedded systems is the lower level here, right? So it converts the higher level commands, as in move from point A to point B. How do you move it? So you need to move motor A in some way, motor B in some way. So that conversion is happening in embedded systems, and for that you need real-time operating systems, because you do not want a lag here. Uh, Embedded systems also deal with a lot of sensors, right? Essentially, if you take like a simple 6-axis robot, something that does manufacturing or assembly in a factory, right? So it has cameras, it has its own encoders on each of the motors. Then what other sensors are there? I mean, there are magnetic sensors, end effectors. There are so many types of sensors. So all of the data from these sensors, you record that data, you talk to those sensors with embedded systems. And electrical engineering is for drives mainly, right? Essentially, how much current do you need to drive a particular motor, right? So that entire electrical management that is done by electrical engineering. So to sum up my entire discussion on domain of robotics, it is an extremely multidisciplinary field where you have people from every single domain that come together to create a product, right? Uh, the people who bring all of these together are called system engineers, whose only task is to ensure that whatever the control system engineer is designing is actually can be implemented with code that whatever system he's assuming is actually the thing that is developed by a mechanical engineer, right? So their only task is to make sure that everything works together and well. So this is a roadmap to learn robotics. Now it may sound silly, but you cannot master everything. You should not master everything, right? It is impossible. Generally, you should have a working level knowledge of all the other fields. Like you should be able to master in maybe about 2 or 3 of these, and rest everything you should just have a working knowledge. Generally, what does it mean, how does it work, something like that. But you should be a master in 1 or 2 of those. No job will ever expect you to know all of these. There are multiple teams, of which you will find that person A has a specialization where he knows these 3 things, person B knows the other different 3 things, right? But having said that, you may develop an interest in any type of, let's say, domain, right? It's not necessary that you have to like design itself because you're mechanical engineers. For all you may know, you may really love to do machine learning, right? So that's why I've put in the roadmap for all specific fields, right? I have also given kind of a focus that when you are, so there are 2 options, right? One option is that you go to the internet and you learn. That is a little difficult because people don't stick to their courses to the end. So the option 2 is to do the courses that NIT Trichy already offers, right? Specifically in during my batch, we had all of these courses. So the most important courses I think for robotics would be math, which is like the fundamental foundational courses, right? Vector algebra, matrices, and differential equations. Without these 3 courses, robotics will become extremely difficult to do anything in, right? Especially from a mechanical side. Once you have that foundation ready, then you have your standard mechanical courses, right? Mechanics of machine 1, mechanics of machine 2, strength of materials, being able to actually design CAD systems, do kinematic analysis, structural analysis. All of that gives rise to the mechanical design part of it, right? Now once you have that, you want to put some kind of actuators, right? So for that, oh actually I forgot to put that in here. You need to put some kind of actuators. So you should be really good with motors and sensing. you should know all types of motors, right? Servo motors, stepper motors, DC motors, high torque motors, geared systems. You will see there's a lot of overlap between the mechanical part and the electrical part, because yes, you have a motor, right? But what should be the RPM, what should be the gearing ratio, what is your link weights, will all feed into the electrical design of it. That, which is why I've been saying it's very multidisciplinary. You will have multiple encoders, so you need to know curve fitting techniques, calibration techniques. Then so now I'll not repeat the control system part, but then again, there is a course from electrical engineering which offers, it's an open elective which offers complete knowledge on control systems, a decent bit of control systems. So you can do that in particular. There's a neural net, there was a neural network course from computer science department, no, it was from electrical electronics engineering, actually, ECE, which also teaches you neural nets, deep learning basically. So you can do that course. There's an excellent image processing course from never neglect your health, right? People are chill, people don't exercise much. It does hurt in the future, 4 years, 5 years, 6 years later. So absolutely, please focus on your health. Go run for half an hour, 1 hour every day. Go to the gym. Please start taking care of your health. That is one. Two, it's my personal regret that I did not publish during my internships and all, which I should absolutely have. Trust me, I could have gotten into better universities if I had published, right? And if you don't, and I'm not at all saying that you should publish in a random journal which has no impact factor just for the sake of publishing. Rather, it is a motivation that you do proper good research with good professors and get it published. You may say today that, hey, I don't want to go for masters, or I'm just going to get a job, why does it matter? I said the same thing, right? I was like, I'm going to get a job, but for good or for bad, I ended up coming here, right? And then if I had published, it would have helped. So getting paper published really helps. But the good silver lining is that I actually have 2 papers under review right now for all the work that I did during my masters. So that's a personal victory for me. When I started, essentially working on my projects, NIT Trichy had a really bad prototyping facilities, right? So I've worked at IIT Bombay, ISC Bangalore labs. I've worked significantly at UCLA, and the prototyping facilities were amazing, right? You could print any material you want. You could use a CNC. You could waste as much material as you want, as long as you were trying to build something fruitful, right? So I'm not sure what is the situation right now, but it is extremely critical that, especially as mechanical engineers, that not only that you will learn design. Obviously everyone learns design, that's easy, but how to manufacture that part, the manufacturability aspect is extremely critical that people tend to miss. And most of the interviews, they will question you on the manufacturability aspect. How do you manufacture things? What are the pitfalls? They will ask you those questions, and if you do not have hands-on experience, you will probably not be able to answer those questions. Which brings me to my next point, right? All the interviews that I've had, every single one of them focused and gave a lot of importance to hands-on experience. This is your chance. Just get your hands dirty and build stuff with your hands. And then when you realize the problems in doing that, that is what employers are looking for. The last thing I'll say is, I think here is where NIT Trichy was really lacking, right? That they segmented subjects per department, right? Like, hey, this is only CS, this is only electrical, this is only that. And it was very difficult to get access to the other courses, which is not at all the case in UCLA, and it is not at all the case in industry as well, right? A lot of the problems that I work on right now at Applied Materials, they need programming, they need motors, stepper motors, actuation. Essentially they need, it's a mechatronics project basically, right? They need proper mechanical design knowledge, they need everything, right? And which is why, especially because I know that mechanical department does not give a focus on C++ and Python, please learn those languages. It's extremely important and critical that you learn it. For the next 5 years you may be fine, but after that, every single motor, every single component is becoming smart. It's becoming smart, right? So for you to be able to talk with that particular device or object, you need these two languages. The last thing, AI. Everyone keeps on talking about it, but it's like, oh, we don't care because we are mechanical engineering, right? I recently used ChatGPT to generate codes for my project, with basically prompt engineering, and it gave me code which would have taken me at least a month to write. So what I'm saying is that as you are building your core skills, core department skills, you should also check how AI is impacting your own field. And the only way that you can do this is not at NIT 3G. is when you go to the internet, when you start learning about how they're using generative AI in modeling. Essentially, we have generative AI in modeling where you just tell that, hey, you want, let's say, what part you want. You can give a few supports, and it will generate that part for you, right? You don't need to go and model every single surface parametrically. So you also have to start learning about how AI is going to impact your own department, right? Which I am doing, but I think you should also do that. Now, based on the knowledge that I have given about robotics specifically and control systems, these two projects that you see here are, one of them is path planning and one of them is control. So if you see, you know that if you have a car cannot move to the right. It can curve right, but it cannot laterally move right. So in that situation, you have to start from this point, you have to end at this point within this particular circle, and you have this obstacle, right? So how do you create a path? As a human, it's very simple, right? You can just draw a line like this. But for a computer to do that and to ensure that a car can actually drive on that path, you use something known as RRTs, or rapid random trees. So this is one of the methods in which you can create a path through space which has obstacles. The next project is controls, right? Where this particular drone, this is a drone. I mean, if you can see, it has like a X here. This drone is trying to fly from this point to this point. So it is generating a trajectory, it is applying a thrust with the four motors, and it is trying to reach the other end. These two projects, the left one I've made in MATLAB, the right one I've made it in Python. When I left NIT Trichy, I did not know Python, which I kind of regret not learning. But I learned it and I made this project. The message here is, if you try and if you're really dedicated, you can do it, right? And with this, I will end kind of my talk. I have a few things to tell you about my master's journey, but I will take questions first, and then if you have any specific questions about masters, I will gather those, and then I will talk about whatever advice I want to give about the master's journey.
Sure, sir. So we have a couple of questions asked by the audience.
Okay.
So so the first one was like, what exact electives do you suggest to get into robotics? I guess you have answered it multiple times, saying control engineering course, the computation course, MEMS, like that. So I'll move on to the next question, sir. How did you chart your exact career path? For example, my ambition is to become an aerospace engineer with a specialty in propulsion engineering, but I don't know how to build a path.
Oh yeah, so I think that was one of the things which I forgot to mention. Be open, right? I did like this field, but I was open that whatever opportunity I got, I took it, right? Never be extremely specific that, hey, I want to go into propulsion system. I'm not. I appreciate that, the fact that you like that field and you want to go into it, but in your UG stage, be open to opportunities. That is first. Second, for propulsion systems, I don't think I am the right person for it. What I know is, in propulsion systems, they use sliding mode control. So it's a lot of control systems that you need to use. Essentially, when a rocket flies into the air, the fuel that actually moves around in the tank itself, it's called slosh. It's called sloshing, right? And then when a rocket moves, it has to turn, right? Or if you have seen, Elon Musk's new rockets, they land back as well. So that is where you need a lot of control engineering. So again, it's a multidisciplinary problem where you have aerospace, you have control structures, fins and all of that, and that is one. And then you have your thrust control, and those two come together to give you essentially propulsion systems, right? So electives, I would say control systems, aerodynamics, CFD, heat transfer, uh, all the core mechanical courses. But yeah, apart from that, control systems extremely critical for that.
Yes, sir. Thank you. Also, if you have any other questions from the audience, please go to the chat box. And also, first of all, congratulations, sir, for getting 2 papers under review. We hope that gets published.
Yeah, I mean, thank you.
Wishing you, sir. So we also have collected few questions from the audience yesterday. So I like to ask that. So with a background in design from mechanical engineering, how should I start my career towards designing in robotics? Like what knowledge specifically is needed?
So I think the good answer, the easier answer is it's not very different, right? I mean, as long as your fundamentals are clear, right? A robot is essentially a system as well, right? The only thing that you need to bear in mind is you have to kind of keep the weights of the entire system low. You have to ensure that what is your end goal, right? So for example, every robot has a different end goal. If you want a surgical robotic system, right, for that your end goal is that the what do you say, the RCM point, right, the point which does not move, that should remain fixed. So for that you will have a separate set of kinematic constraints, right, that no matter how the mechanism moves, that one point should not move. That is a different set of mechanical constraints. Let's say you want to make a robot dog with two legs, like you've seen the Boston Dynamics, that dog, right? For that you want the robot to run as fast as possible. That is their goal. Again, different constraints. So for you to start designing for that systems, you need to think in terms of constraints, in terms of requirements. What do I really want from this particular mechanism? What do I want from this design? And based on that designs, you start charting what gear ratios I should use. You can come up with a fancy mechanism, but if the electrical guy says that, hey, I cannot make this motor, I cannot physically manufacture this type of motor which can give you that much force, your design is useless, right? So you also have to take in constraints from your electrical guy, and then first you put all the constraints together and then come up with a design. So the fundamentals are the same, right? Whatever you study in mechanical engineering, all the core courses, but how you apply it, that is the real question.
So what does robotics companies expect from mechanical undergraduates? Like, does a background in controls really helpful for somebody to get placed?
So okay, so here is it really depends on the company, right, and the type of role. So if the role specifically says mechanical design engineers, then a controls knowledge is helpful but not required, right? But generally, so it really depends on the company how they're looking to hire. So I mean, I'll say it that way, right? It may be helpful, maybe not. Depends on the company. I had a few things to tell specifically for people who may apply for masters, right?
Yes.
And even for job, right? One of the things that we do not do is to make a portfolio, right? It is extremely important in the US and even in India to make a portfolio. You can describe something in 5 sentences and the interviewer or your professor will not get it, what you're trying to say. But if you show one photo, he'll get it instantly what you did, right? And so you can host your portfolio anywhere, Google Drive, Google websites, GitHub, does not matter where. But having a portfolio will really boost anywhere you give interviews. Even if you're applying to any internship position with a professor, even if you don't send your resume, it doesn't make a difference. You should send in your portfolio. If your portfolio is good, he will hire you just based on that, and which I have been doing multiple times, and I've gotten feedback that the portfolio was really great, right? So please make a portfolio, guys.
Yes, sir. So I guess there's a question from a DC guy as well. So how was your personal experience with your Sangam project? Because
Okay.
we have Sangam right around the corner, so next week.
Oh, okay, interesting. So I think we won third prize, I guess. Also, an interesting story, right? So my Sangam team, or like the DC Sangam team, right? We had 4 people, of which 3 of us ended up at UCLA, right? So that was like absolutely. I knew those two of my friends since like 4 years at NIT Trichy, and then all of us went to UCL as well. So it was like a very interesting experience. But yes, in terms of my Sangam project, a lot of late nights were put into it. Kind of like my first projects in that sense, where I took my basic designing skills that I learned over a course and actually applied it to a project. A lot of things we kind of messed up as well, but eventually the satisfaction that you get when you see a project, functional project, and it wins something, that feeling is like, at that point of time in life, that's really important, and that gives you motivation to do better things in life. So great experience, right? The nights that you have put into it are all worth it when something great comes out of it.
Yes, I really get that victory thing.
Yeah.
So, also, I really want to ask, like, how did you switch your career from designing to robotics?
So it's
Like, you start off with designing, right?
So right now I do a mix of both, right? So right now my career is like mechatronics, right? I've done robotics, but right now my career is mechatronics. It involves both. It involves kind of programming and as well as design. So I've not really switched my career, but let's say expanded the scope of my career. So I'll put it that way.
Oh,
Yeah.
so I mean,
the motivation is what I already mentioned during the call, right? That I could design something, but I wanted to move it, and then how do I move it? Then I learned everything.
Yeah. Then you start with controls, and then you start with perception.
Exactly.
Yeah. And also, what are your current projects?
As in my company?
Yeah.
That is confidential.
Okay, I got it, sir. Okay, sir. Yeah. Anyways, audience, do you have any other questions?
Wait. Okay. Yeah, I think I have a couple of more things to tell, right?
Yes.
So you have to understand, as I already mentioned, resume is not a sprint; it is a marathon, right? You cannot suddenly wake up in third year and say, hey, I don't have anything for my resume. You have to start right now, first year, second year, third year. Every vacation that you get, definitely make sure to do something with your life, right? That'll really help you a lot. Always remember that even if you have learned something, there are bigger fish in the sea. There will be people who will be better at that particular thing that you think that you are good at. But the key is to essentially not be complacent, but be content, right? You have to feel good that you learned that thing. Absolutely feel good that you have learned it. You have put in the efforts, you have learned that thing. But don't be complacent. Don't be like, oh, okay, fine, I've learned it, I'll not learn more. Never do that, right? Always hands-on approach beats everything in life, right? Because you will see the problems even before you start working on the project. Theoretically, in the model, everything works great. In real life, everything is messed up. And it's not only true about mechanical, it's true about electrical, it's true about simulations, everything, right? So hands-on work always beats everything. What else? Yeah, I mean, enjoy your 4 years. Honestly, they really go very quickly, and then essentially after 4 years, you'll kind of miss college. So please learn to have fun. That is very important. Procrastination, right? I think I really suffered from that when I was in my. So please somehow develop, try to not procrastinate. Try to do things on time. Assignments, exams, studying for exams. I did not, but I kind of regret it now. So I'm telling you that you will not regret it. Most important for anywhere you go in the world, soft skills, the ability to talk, the ability to convey what you're trying to say in a concise way, very important. And then if you can build up a reading habit, please do that. That is also important. If you want, I can talk specifically about MS, college selection, but that's only if someone wants it specifically. I don't know what is the demographic, what year are these people. So
I mean, we would like to have it, sir, because a few of us would really like to apply for masters.
Oh, okay.
So it would be helpful for them.
Oh, absolutely. So the most important thing is you first should do even before you start applying for masters or thinking about it, you should first look at yourself. What have you done in life? How does a master's program benefit you as a person, right? some people just like, oh, I don't want to study, I just want to get a job in the US, so I'll just do any masters and then get a job. In the long term, you will suffer a lot, because people who get random degrees do not really progress in their career. They stagnate, right? So you should always choose a degree that is going to complement your career and put you on a path for success, right? That is one. Two, there are really great websites like US News. Probably you can use Yocket and all of that to look at rankings. They really make a difference. So one thing that people tend to ignore is the location part of it. People say, oh, fine, I will go to Virginia, for example, because it has a lower cost of living, right? Fine, it has a lower cost of living, but eventually when you're looking for jobs, most of the jobs, they are either on the west coast in California or on the east coast near New York, Boston, somewhere there, right? And then it becomes difficult to get jobs if you are from like a remote location. So location of your university matters a lot. Then funding, right? So I was lucky enough that I got funded for 3/4 of my degree, which means essentially someone who's determined enough can get that degree completely free. Imagine getting a master's degree from a great university for free, plus getting enough money from the university to pay all your living expenses. So if you are, essentially good with your application and smart about it, you can get a free master's degree plus three years to work in the US. So there's like nothing better than that. Essentially, yeah, as I said, like ranking and reputation really does matter. And as always, networking, right? So the day that you land in the US in August or September, you will start applying for internships. And if you have a connection, if you have your own personal network in the US, if you know seniors, they can refer you, and your internship or job search will become 10 times easier. And that's true about the US as well as India. So again, reiterating my last point, networking is extremely critical. And I think the one last thing is, there is this Bob Ross quote, right? That we don't make mistakes, we just have happy accidents, right? So it's fine. Not everything in life will go according to plan. Not everything in life, you will mess up in a few things, but it's okay. It's okay. You just get up and you move on with your life. That is the last message that I have. That is with what I want to end this on.
So that was really, really insightful hearing from you, sir. Especially the roadmap to robotics, your experiences and projects that you worked on. And yeah, so we officially come to the end of the first episode of SYNC. We extend our heartfelt gratitude for you coming and sharing your valuable time with us.
Thank you. I just wanted to put this out there. So, you guys can, if anyone has any questions, if you want to reach out, you will see my email address, my LinkedIn on display here basically. So please feel free to reach out. I'll be happy to help. Although if you're sending me a request on LinkedIn, just make sure to put a note that you're from NIT Trichy, something like that, because I get a lot of requests on LinkedIn. So just make sure to put that note. Okay?
Yes, yes.
Yeah. Thank you. Yeah, again, it's been a pleasure for me as well to talk about my experience. So thank you so much for the opportunity.
Thank you, sir. Thank you for coming, sir.
Yeah. Okay. Bye.
Bye, sir.
Thank you, everyone.